Hello everyone. Today we are going to talk about 5.2D graph of polynomials. So before we start the lesson, can you start your do now? So you have two functions are here. Can you determine algebraically whether these functions are even, odd, or neither? I'll give you 5 minutes. Okay, let's go over together. So algebraically, when you determine the functions are even, odd, neither, what do you do? Yes, we compare f of x with f of negative x, right? So we are going to find the f of negative x. So now, like this. So f of negative x, you replace x with the negative x. So negative x cubed minus 2 times instead of x, negative x. And then simplify. So negative in the third power, so odd number power become negative. So negative x cubed and negative minus become positive 3x. If you compare this with the original function, what happens is all the terms change the sign, right? All the term change the sign. Obviously, it means you multiply negative to the f of x original function, which is its odd function. If you look at the original equation, you can see it's odd or even immediately, right? The exponent 3, and you don't see here, but it's 1. So all the exponents are odd numbers. Then it's odd function, right? Then number 2, if you see it, this is 2, this is 1, this is 0. Even, odd, even. It's mixed. Then what do? If it is mixed, it's not an even function, it's not odd function, which means neither. But we should show it algebraically, so you should do that g of negative x, right? So g of negative x is 3 negative x squared minus 4 times negative x plus 5, and then simplify negative in the even square, it becomes positive. So again, 3x squared minus negative become positive 4x, and plus 5, there's nothing to replace, so just 5 as it is. And then look at compare with this original function. It's not exactly the same because this and this change it. So not every sign changed, only one of them. So it's not equal to original function g of x. It's not equal, right? And it's not equal to negative g of x because not everything changed the sign. So you need to write down this, and then answer is neither. Everybody understand, right? Okay, let's go to today's lesson. So what are the most important elements for when you graph a polynomial function? Can you think about it? What are the most important elements? So first, about 5 things. But most important is 4 elements. You are going to find the 4 elements. But here I can say 5 things, which is end behavior. You know end behavior, right? If you know the degree, this is degree 3, and this is degree 4. Then how many times it curve? 4. This is 4 times. 1, 2, 3, and 4, like this, right? This is a degree 3. 1, 2, 3 turns. Not all the time, but it's usually like this. And then, so odd degree, both ends go different direction. Even degree, both ends go same direction. Positive, right side always goes up, right side always goes up. If it is negative, going down, right? Then upside down everything. And then we should know zeros. You know the zeros. How many zeros are here? 3 zeros. How many zeros are here? 4 zeros. You need to find all 4 zeros and write down in the here in the x-axis what are the value of zeros. 1, 2, 3, 4. You better write down. Okay. And then what is y-intercept? Y-intercept is the easiest one, right? So when x is 0, y value is 0. So here, oh, this is y-intercept is also same with one of the three zeros, right? Here, when x is 0, y is 4. So this is y-intercept. And we should know relative minimum and maximum. It's not familiar, right? Then I will talk about it. It's not difficult. So relative minimum and maximum. And then you look at the table in the calculator to find the exact coordinate. You should plot them by looking at the table and connect them all like this and draw the graph, right? Make sure you draw the x-axis, y-axis. Even though you don't see y here and x here, you should write down, okay? And then origin. Label, please. Interval must be very even, okay? Interval must be even. It doesn't need to go by one. You can be flexible depending on how, okay? But better to go x better to go by one, but y can be flexible, all right? Y can go by 1 or 2, 4, 6 like this, or 3, 6, 9. It's up to you. All right. Then today we are going to focus on how to find out zeros and relative minimum maximum by using calculator. But you know how to find the zeros, right? Because we did it. We found the zeros by calculator, by using calculator for the quadratic equation. You remember? But we are going to practice again. So let's, before we do it, just remember what's the relative maximum? It's the highest point in a particular section of a function's graph. So for example, this has a weird graph, has so many, so turning point, turning point, turning point, turning point. Then this is a relative maximum, this is a relative minimum, this is a relative maximum, right? So turning point, turn, hit the maximum and go down, right? And then this is another turning point, hit the minimum and go down, right? So this we call relative maximum, and this is we call relative minimum. So relative minimum is the lowest point in a particular section. And this is a relative maximum, this is a relative minimum. Everybody get it right? Then let's find them by using the calculator. So you have a function f of x equal to x to the fourth power minus 6x squared plus 4. This is domain. If you look at this, you are going to draw the graph, but not all the x values, only between -3 and 3. If you see the domain. If you don't see the domain like this, then you need to show the arrow in the both ends, right? Which means keep going to the left side and right side. But here it start from -3 and end at x equal to +3. All right, that's the meaning of this domain. So now we know what is y-intercept, right? Y-intercept is 4 because when x is 0, this is y-intercept 4. So that's easiest thing to find. And you know the shape of the graph is x to the fourth power is this, right? How many times you know? How many times you turn? 1, 2, 3, and 4, like. But if you look at the graph, you know, shape is not, the calculator will show you the shape, but you should know how it looks like, because sometimes calculator cannot show everything. You should imagine the shape of the graph. All right. Then let's find the zero first. Look at the graph. But you remember when you find out the so zeros and maximum minimum, same thing, or you go to the second calculation, which is trace here, right? Everything same. All right. So go to the second calculation, and then you are going to find the zeros and minimum and maximum, which is a relative max and relative minimum. All right, so let's do it one by one. Look at the graph. So if you look at the graph, it looks like this. And then if you look at the calculator table, -3 and y value 31 is but because I cannot show here the 31, I just wrote down -3 and 31. All right. And +3 and 31 is ending point. But now we need to find out 4 zeros and how many relative minimum? 1, 2, 2 relative minimums and 1 relative maximum here, right? We need to find them and write down the label them, okay? Each point. And then connect them like this by looking at, before you do it, also look at the table and then, plot each points, all right? Now, let's find the 4 0, but 1 0 at a time. Okay, I want to find this one, all right? And then the other one, you can find it. Repeat the same step again and again. So, okay, so if you do it, you will have 4 zeros like this, -2.29. This you should write down here, and negative 0.87, 0.87, write down here, 2.29. But I will show you now how to get these 4 zeros, but I will show you with this one, the first one, all right? Let's do it together by using the calculator. So I'll open this. Now, you know how to put the function in the calculator, right? X to the fourth power minus 6x squared plus 4. And look at the graph. Yes. Now I'm going to find this 0. What's the first thing to do? Yes, second trace here, which is a calculation, second trace. Then 2 is 0. Relative minimum is this minimum. And relative maximum is maximum. So everything is here. So now let's get the 0. So go down and enter. Then we are going to find the 0 here. Where's the cursor? We should find out, right? Where's the cursor? Yeah, here, right? If you move and then this is 0. This is the left side. You go to the left, right? And you go this way, go to the right side. So from here, you left bound, set the left bound. So this cursor must be in the left side of this 0. And then enter. Then what did he say? Right bound. You need to settle. So you move this cursor to the right side. Move to the right. Oh, just one time it goes to the right. This is good enough, right? And then it's in the right side, then you enter. Do you get the answer? No, it's not 0 yet. What did he say? It's a guess. You don't need to do anything. Just what? Click one more time, enter. Then it says 0, right? And then y is 0. That y equals 0 means 0. So what is x value? -2.288, which is -2.29, right? So if you repeat this step, same thing over and over again. For this one is left bound, the right bound, right? Left bound here, right bound here. For this one, left bound, right bound. This one, left bound, right bound. If you do it like this 4 times, you'll get all these 4 zeros. All right? Like this, also relative minimum, relative maximum, also same thing, right? Relative minimum, and relative maximum, which is y-intercept. But to make sure you can do it in the calculator. Let's try relative minimum. You know how to do it, right? What do you do? Second, trace with the calculation. Now let's do the minimum. Here, enter. Minimum is here, right? You don't see the point, but we know that here because you should, if you remember end behavior, you know the shape of the graph, degree 4. Then like this. Oh, here's minimum. I'm looking for this minimum, okay? Left bound is in the left side. Yes, cursor is in the left side. Make sure you move the cursor, and then if sometimes if you don't see it, keep moving around until you see it. So now enter. Right bound. How do you, let's move this cursor right side, right? One, still, oh, it's gone, but it's moving. So don't worry, keep moving until you see it. See it? No, oh, no, yeah, you see it, right? You can move one more time, doesn't matter. As long as you here in the right side of this point, right? And then you click enter. Guess, same thing, enter. Do you see? Minimum is negative 0.173 and y value is -5. This coordinate you should write down when you draw the graph, right? And then if you do the same thing for this point, you'll get 1.73, positive 1.73. All right, and -5. For relative maximum, let's try together. This one, then second trace. I will do it quickly now. Maximum 1, 2, 3, 4. Enter. Now I'm going to where is the cursor? Oh, now I need to move here. Left, now it's in the left side of this point, right? I'm doing enter. I'm going to move now to the right bound. So right side. Move, 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 move. Now it's in the right side. Enter. Guess. Enter. So 7.1. Oh, E -7. E -7 means how many 10 divided by 7 zeros, which is 10 million. So 7 divided by 10 million is almost 0. So sorry, but sometimes your calculator give you like this. E -7 means divided by 10 and 7 0, which is a 10 million, right? So it's almost the same with the 0 value. That's the way the calculator works, but just understand this way, all right? E -7. E negative some number, negative divided by that many zeros. So this is x is 0, right? Here's x is 0 actually. And what is y value? Y equal to 4. So x 0, y 4. That's the relative maximum. All right. Then we are done. So you got all the necessary points, right? And then you know how to look at the table here. You go to the second graph. You look at the table, -3, 31, -2, 4, -4, -1, -1, 0, up to 3, 2, 31, right? Up to here, you plot all these points in the graph along with zeros and relative minimum, relative maximum, relative maximum, and then connect. It's not straight line, okay? It's curve, 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 curve. If there is no domain, you put the arrow in both ends, all right? If there is ending, then put the points -3, 31, and positive 31, right? And then that's the graph. It takes long, but simple, right? So can you draw all the other graphs? You know, you can practice it by yourself and then hand in. All right, we'll stop here.